Hello, friends. How are you? This is the third video on the topic called beams. Beams. In the first video, we saw all the basics of the beam, and in the second video, we solved one problem which involved the inclined load and bracket load. Now, in this video, we will solve one problem which will be having a nonlinear load. Nonlinear load is a load which is not neither UDL nor UVL. Now, what is UDL and UVL? For that, you need to see the video called Types of Loads. So, you will understand it quickly. So, nonlinear load, which will be the load which is not normal, which does not follow any pattern. It will be having an equation in terms of x and y and with some boundary conditions. So, applying some mathematics, we will solve and simplify that load and apply equations of equilibrium. So let's get started and solve this problem. Engineering Fundamentals Guidance by Somayya Sir, Pune, and I am Yugandhara Tadale. Content of the video is Introduction, then beams, its definition, what is static determinacy of beams, types of beams, then some problems that will be with linear and non-linear loads, problems on compound beams, and problems on beams with internal hinge. Now we will solve the beam with non-linear load acting on it. We will solve the support reactions for the beam. This is a simply supported beam with a non-linear load of equation y is equal to cx square is acting along the full length of the beam. So let's solve it. This nonlinear load whose equation is y is equal to cx square is plotted such that the distance is along x direction, which is in centimeter, and intensity is along y direction, which is in Newton per meter. We have considered a strip at a distance x from support A whose length is dx. Support reactions at support A and B are taken. As A is a pin support, there will be two components, and B is a roller support, there will be one component of the reaction perpendicular to the roller. As we have considered this strip of length dx at a distance x from support A. Now we will apply this equation at x is equal to 8, that is at B. The intensity Y is 640 Newton per meter. It is given. So after putting that values in the equation of load, we get value of C is equal to 10. So the equation becomes Y is equal to 10 x square. Now we will find out the area under the curve. As we know, it is from 0 to 8. The limits are 0 to 8. And integration. By integration, we can find out the area under this curve. We have the equation of this curve. We have the limits. So we can find out the area. So it will be integration of y dx from the limits 0 to 8. and inserting the value of y as 10x square, we get 1 by 3 of 10x cube from the limits 0 to 8 dx. After putting the values of the limits, we get 1706.67 Newton per meter into meter. That is 1706.67 Newton. Now we will find out moment of this area about y-axis. That is summation of A into x. Why we will need? We will see in the next step. So now summation of area into x, that is moment of area about y-axis, as the equation A into x. So integration of y dx into x from the integration limit 0 to 8. After putting the value of y and integrating, we get summation of ax is equal to 10240 Newton meter. Now we want value of x bar, that is summation of a into x upon summation of a. Summation of a will get cancelled and we get x bar. So what is this x bar? It is the distance at which the center of this load is there. So summation of Ax value and summation of A value are inserted in the equation and we get x bar is equal to 6 meter. So we can simplify this nonlinear load as like this. The load is acting at a distance of 6 meters from support A. This is the CG of this load and the intensity of load is 1706.67 Newton. So for this nonlinear load which was given in the question of the equation y is equal to cx square, it can be simplified like this. At support A, HA and VA, and at support B, VB, and the nonlinear load is represented by this vertical load of intensity 1706.67 Newton acting at a distance of 6 meter from support A. After applying equations of equilibrium to this beam, we get the reactions as like this. Can you solve them? Thank you so much to you all for being with me throughout this video. I'm grateful for your support. Happy learning! If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.